So running experiments, so that would be so that's another aspect of your work where you might not have data on some of the stuff you want to sort of explore, right? And that's where you'll sort of embark into running experiments. And this is not, we're not talking about just experiments like in a lab kind of a situation, right? It could be an experiment where you're trying to sort of improve sales, right, or improve the process of hiring better, and so on, so right. So these are all experiments we all should run in our day to day lives to sort of make our decisions better by looking at past data and see where we can improve, right? So just to give you an example, right? So Harley Davidson. So I am not sure where I read. Probably it's one of the papers I came across where this dealership somewhere in New York was suffering a pretty lackluster sales, right? And so they sort of explored a company called Algorithm, right? They had this AI driven marketing platform called Albert, right? And so they engaged them, and what this tool was doing is that they were looking at their existing customer relationship management data, right, as to what kind of people actually bought Harleys, right, and how and what this tool ended up doing is they started the tool sort of started out with looking for customers which sort of matched the profile of the customers who bought Harleys and who haven't yet bought Harleys, right? And trying different Facebook and Google ads, or trying different marketing strategies or advertising strategies by segmenting this population into small samples, right? Not the entire population, but trying out with small samples and see which kind of marketing campaign worked to sort of draw inbound traffic into that dealership, right? Onto the dealership's website, to be able to get to a point where they can fill out questionnaires, and then the sales folks can actually go on and close that sale, right? And it so happened that that thing made a dramatic difference in that dealership's ability to sort of scale up in the amount of sort of sales they were making. So where is the experimentation part? The experimentation part was trying to sort of try out different strategies, different way of wording a campaign, different trying out different keywords and all, and so, right? So that's where experimentation comes in, and you will. I don't care what you do, right? You will be doing a lot of experiments when you have a hunch and you want to prove your hunch, and you use data to sort of prove that hunch, right? So field experiments has the power to transform organizational decision making, right? Whether that pertains to product design, to launching effective campaigns, to anything and everything where cause and effect relationships needs to be studied, right? And companies that invest in randomized evaluations can gain a game-changing advantage, just like that Harley example we just talked about, right? And experimentation is a long-term, very richly informative process with each trial forming the starting point for the next, right? So we started off looking at that restaurant business, right, where they were sort of trying a different things, and what works, what doesn't work, and they can hone in on what works and keep on improving on that, right? But there are pitfalls to watch out for, of course, whether with the design or with implementation. So a few steps we're going to go through to ensure that your experiment yields or delivers the data and insights you need, right? And so identify a narrow enough question, so instead of asking if advertising is worth the cost, right? A better question would be design an experiment around, would you like, if asking around if Google AdWords help drive sales, right? And Google has this AdWords things which work surprisingly well, right? And so and spending money on marketing is always like a firm which is basically has it's not the core of that thing, and they always hate a lot of this. Any business would hate spending money on anything, right? So marketing technically is considered to be uh, uh, as opposed to R&D, right? Not as value driven, right? But we know marketing works, right? So no organization wants to spend money that they need to say on, say, advertising and promotions, right? So naturally you want to know the ROI, right? So ROI is always key on different advertising initiatives. But asking a question like, is advertising worth the cost, is basically not the right question, right? Because yeah, are you asking what form of advertising are we talking about, right? Are we talking about online, in which media and what time periods, and so and so, right? So your question needs to be testable. It needs to be narrow enough where so a right question would be how much advertising, as I said, or Google AdWords helps in sort of driving up sales, right? And I think eBay, in fact, I think there is a story about eBay, in fact, tried just that. And at one point, and they sort of found out when they sort of did that experiment or those series of experiments that it doesn't help, right? So for eBay it didn't, but for a lot of other businesses it probably does, right? So that's one instance of asking an error question, okay? And let's say you want to intervene, and the intervention has to be large. So here I have the series of labels, right? But that's probably not explains the example I'm trying to give. But the example is that so companies experiment when they don't know what will work best, right? So faced with this uncertainty, it may sound appealing to start small in order to avoid disrupting things, right? But your goal should be to see whether some version of your intervention, your proposed change will make a difference or not, right? So it has to come out with a bang, right? So this requires a large intervention. So say you're running a grocery store, and you're thinking of adding labels to show customers that you source your products from local farms, right? For example, right? So how big should the labels be? Where should they be attached to sort of advertise that you are basically sourcing all your products from your local farm, right? I think if I were running their experiment, I would want that label to be large enough and bold, because if the labels were small and inconspicuous, right, and if there were no effect, a common outcome for subtle interventions, right? So you will probably see that, oh, there is no effect. So if you're a store manager, you would be left to wonder whether consumers simply didn't notice the tags because they were too small. Because the treatment, you're basically applying a treatment to that packaging or that label. Was that treatment not large enough, or truly did the customers don't care whether the products were sourced locally or not? So that means, was there truly no treatment effect, right? So by starting with a large intervention, the store would, if you're running your store, right, you would learn whether customers actually care about the fact that you are sourcing your products locally, right? And if there is no effect from the large labels, then okay, you have your answer. But if there is an effect, only then you can sort of start tinkering with that label and maybe reduce the size or reduce the effect of that size. So this is one aspect of where a large intervention has to be the case, right? You cannot be certain, right? Of course, perform a data audit, right? So once your intervention is identified, you need to choose what data to look at, right? Make a list of all the internal metrics, all the internal data related to the outcome you would like to influence, and when you need to do the measurements, right? And what do you expect to change, and what won't change as a result of the intervention, right? And you of course want to think about external data feeds as well, right? For example, you say you're launching a new cosmetics product line, right? Uh, and you want to know what type of packaging leads to higher customer loyalty or more sales and satisfaction, right? So you decide to run a randomized control trial across, across many geographical areas, right? In addition to measuring recurring orders and customer service feedback, which is internal data, right? You can track your user reviews on Amazon or stuff like Amazon and platform like Facebooks and all those things, right? And look for differences amongst customers in different states, external data as well, right? So this is like part internal, part external data where you can sort of explore different data feeds, right? And are you studying the right population, right? This is another thing about experimentation where you want to choose a subgroup amongst your customer that matches. Okay, I'm talking about customers, but it could apply to any place where, for example, when I am in my world, right, we are looking at different changes of different material sets, for example, on products performance, or different design flavors of a product on performance, right? Because I'm in the hardware world where we actually build IC semiconductors, right? And we want to be able to see the impact of different material sets, different design strategies on the eventual outcome, which could be price, performance, and so, right? Reliability and all those things, right? So you want to study the right problem. You want to choose a subgroup amongst your customer that matches the customer profile you are hoping to understand, right? So it might be tempting to look for the easiest avenue to get a subgroup such as your online users, because that's data you would have readily available, but that might not be a good representation if your target customer set for that treatment happens to be older customers who don't frequent online and who would rather frequent a brick and mortar store, right, than shopping online. So using online purchases and applying it to physical stores might not work, right? So that's just one example of studying the right population. And of course, we want to randomize, right? So randomly assigning some people to treatment and some others to control group, right? And the treatment group receives the change you want to test, while the control group receives what you previously had on offer, right? And make sure there are no other differences than what you're testing, and that's hard, right? So the first rule of randomization is not to let the participants of that study decide which group they are in, or the results will be meaningless, right? Because it's one thing to sort of separate the control and the treatment when you're dealing with objects, right? But it's a completely different ball game when you're dealing with people, right? And the second rule is that you really want to make sure that no other differences other than what you're testing for exists between the treatment and the control group, which is, it's not always easy to follow the second rule. For example, we have seen companies experiment by offering different coupon on a Sunday versus then on Monday, right? But the problem is that the Sunday shoppers may be systematically different from Monday shoppers, right? Even if you control for the volume of the shoppers on both days, right? So you can be deriving any conclusions from folks who shop on Sundays, which could be busy people, versus folks who shop on Mondays, which could be folks who are technically retired, right? So and commit to a plan and stick to it, right? So before you run an experiment, lay out your plans in details, right? And it's very, very easy to sort of get derailed on your plan, right? So how many observations will you collect? How long will you let the experiment run? What variables will be collected and analyzed? Record these. So this basically has a way for you to make yourself accountable to your experiment, right? And what you're trying to assess. So once your experiment is running, leave it alone, right? If you get the results you expected, fine. If not, that's fine too. The one thing that is not okay is running your experiment until you get the data you need, or until you get the results you're looking for, right? As though they fit your hypothesis, rather than until the study actually has run its planned course, right? So you don't want to sort of tweak your experiments in such a way that you're letting it run until you get the data you need, right? So and that's sort of playing around with the data, right? Which is never good, right? So, and let the data speak, right? So did you get the effect you expected? If not, why? Can you refine your experiment and run another trial to learn more, right? And so that's and that is this whole new world of A/B testing. So Ronald Fisher, right? So A/B testing is I sort of alluded to before, right? So it's a way of comparing two different versions of something to figure out which performs better, right? Well, it's most often used today with website and other things, but it's been in existence for 100 plus years, right? Ronald Fisher, I think, is a British statistician between 18 sometimes. I guess in the 1930s or 40s, right, discovered the most important principles behind A/B testing and randomized control experiments, and he did that on agriculture, right? So, what happens if you put more fertilizer on this land, right? And the principle persisted through the 1950s, and started, and then the applications went to medicine, and then to direct response campaigns in marketing. Like for example, would a postcard letter sent to a target customer result in more sales, right? So something like that. And we have this modern version of that now, right? So over all the years, the underlying math, which we are definitely going to go into, right, hasn't changed, right? Same concepts now, but we are all doing it online in real time a lot of the times, and on different scale in terms of the number of participants and the number of experiments we run, right? And the size of the so just to give you an example, so you could have a website where you have a subscribe button, right? So the size of that button could be a test, right? Say your metric is the number of visitors who click on the button. You then show them two sets of buttons assigned at random to visitors on your website, and you assess which button actually leads to more clicks, right? So the A/B test can be considered the most basic kind of randomized control experiments. In the simplest form, there are two treatments, and one acts as the control for the other, right? And of course, sample size is important, right, to achieve statistical significance, which we're going to talk about. To make sure that the results, you can basically take the results and make conclusive, and you can sort of conclude off of that, because any data is going to have some background noise, right? So you want to sort of get rid of that by having enough samples in your data, okay, or in your experiments. Okay, so that pretty much concludes this aspect of this module. On to the next.